we start with the second property. This is the second case when you have the multiplication by t power n. Okay, so it means you are having the term of this form, t power n multiplied by f of t. So only these two kind of terms will arise in multiplication in the Laplace transform. So in this case, what the property says, if the Laplace transform of any function is denoted by f of s, then the Laplace transform of t power n f of t is minus 1 to the power n dn over dsn times f of s. So again, we are going to use f of t to give you fs and t power n. This power will decide this term. Minus 1 to the power n and dn over dsn stands for derivative with respect to s. Okay. So let's see how this will work for this question. So suppose you need to find Laplace transform of t sine of 2t. So again two terms in multiplication. One is sine t and another is t. So what becomes important is that whenever you look into the question, first check is it possible to use shifting property. If that property is not working, then only come to this property. Because here you have to find derivative, and finding derivative is more tedious compared to just replacing the value of s. So now t means t to the power 1, and here you have sine of t. So as usual, sine t will give you fs, which is now 2 over s square plus 2 square. Now t power n, this nth power is giving you this whole term, minus 1 to the power n dn over dsn. So here the power is 1, so it means n is 1. So what this will give you? This gives you minus 1 to the power 1 d1 over ds1. We did nothing, we just replaced the value of n here. Okay, so now substitute in the formula. So for this one we get minus 1 d1 over ds1 of fs, which is 2 over s square plus 2 square. So now what you have to do, you have to find first derivative. So it is same as like minus 1 d by ds of 2 over s square plus 2 square. You need to find the derivative. So how do we find the derivative? Now it's quotient of two terms. So to find the derivatives, we have to use quotient rule of derivative. So what the rule says, if you have terms of the form u divide v and its derivative, we use this to denote derivative, then it is same as derivative of u times v minus u times derivative of v over v square. So v, when we compare it, the numerator is u, denominator is v. So u is 2, v is a square plus 2 square. Now here we are differentiating with respect to variable s. Derivative of u, it is 0 because 2 is a constant. Derivative of v is, for s power 2 it becomes 2s. For 2 power 2, which is 4, it becomes 0. So derivative of v is 2s. Now we use these values in this rule. So what we will get? Minus 1, because this minus 1. In place of this, derivative of u, which is 0, multiply v, which is s square plus 2 square, minus u, which is 2, multiplied derivative of v, which is 2s over s square plus 2 square, v square. Okay, we just used the product rule, we did nothing else. Now we can 0 multiply anything means this total term become 0. We multiply 2 with 2 and this is minus, this also outside also minus. So what we will get? When we simplify it, we will get the answer as minus minus become plus, 2 times 2 become 4, s over s square plus 2 square and its power 2. So this becomes the final answer. Now for derivative, if you don't want to go by quotient rule, you can work in another way. Like you have to find d by ds of 2 over s square plus 2 square, right? You can also write it as d by ds of 2 times s square plus 2 square to the power minus 1. And here make use of chain rule. So it is 2 times minus 1 s square plus 2 square power minus 1 times the derivative of s square plus 2 square. So when you simplify it, it will give you minus 4s s square plus 4 to the power minus 2, which is minus 4s over s square plus 4 power 2. You will get the same answer. Here you are getting positive because we are calculating the value of plus of d by ds. So if you have minus here, you will get minus here, you will get minus here, one more minus sign, so this will become plus. But the method remains same. So when we take this next example, we have to find Laplace transform of t cos of t. So again this rule is working with it. T power 1 means n is 1, so it stands for minus 1 d by ds. Cos of 3t gave you fs, which is s over s square plus 3 square, which is 9. Substitute it in the formula. Minus 1 d by ds s over s square plus 9. Again 2 terms in quotient, use quotient rule. So when we use quotient rule, we have to compare the value of u and v. So what do you have as u? This term is u, the denominator is v. So we work in the same way. U is s, v is s square plus 9. Derivative of u with respect to s because of ds. So s means s power 1, derivative is 1. Derivative of v, it is 2s. Substitute these values in the rule. So it will give you minus 1. This minus 1 we are writing same. Derivative of u, which is s times, derivative of u is 1, not s. So it will be 1 times v, which is s square plus 9, minus u, which is s times derivative of v, which is 2s over s square plus 9 and power 2. Simplify it. Minus 1. 1 times s square plus 9 gives you s square plus 9. S times 2s gives you minus 2s square over s square plus 9 power 2. Okay, then this will give you minus 1 minus s square plus 9 over s square plus 9 power 2. How do we get minus s square? because we combined these two terms, s power 2, s power 2. Here the coefficient is 1, here minus 2. So it gives you plus minus 1. Okay, then multiply this minus sign inside to both the terms. Okay, so what it will give you? It will give you minus become plus, s square plus minus become minus 9 over s square plus 9 power 2. This completes your solution. So in this question you have multiplication of t power 2 with e power t. So you can solve this question in two ways. You can answer it by using shifting property, or you can answer it by using the rule that we studied just now, multiplication by t power n. So when you use shifting property, what you will be using? Fs, s replaced by s plus a. Whereas in multiplication by t, you will be using dn over dsn fs. Okay, so now here you have to be clever to save your time. So if you use shifting property, say if you are using shifting property, what will happen here? Laplace transform of t square e power t. So this term you are using to get fs, which is 2 factorial over s power 3. This you are using to give you the value of s. S replaced by, if it is plus, make it minus, the coefficient of t is 1. So you will get the answer as fs, s goes to s minus 1. So it is 2 factorial over s power 3, s goes to s minus 1, which gives you 2 factorial of over s minus 1 power 3. Okay, so this is one way. On the other hand, when you use this rule, multiplication by t power n and this one, so you will be using that rule. So it will be like this. So t power n, so this means minus 1 power 2 d2 by ds square. This gives you fs, which is 1 over s minus 1. How do we get it? Because Laplace transform of e power minus 8a is 1 over s minus s plus a. Okay, now so when you put it in the rule, you have minus 1 to the power 2 d2 by ds square 1 over s minus 1. So it means the power 2 means you have to differentiate 2 times. Here you have to differentiate 2 times. Find derivative 2 times. Because of this power 2. So see, it will be time consuming. Okay, so let's see what will happen. We can make use of chain rule in this case if you don't want to use quotient rule. Minus 1 power 2, this will become plus 1. So we write d2 by ds square. I can take this s minus 1 in the numerator, which will become s minus 1 to the power minus 1. So let's work out with this term, s minus 1 to the power minus 1. When you take the first derivative, what you will get? Minus 1 s minus 1 to the power minus 1 minus 1, that will give you 2. Sorry, wait a minute. That will give you minus 2. okay, minus 2 times the derivative of s minus 1, which is 1. Okay, so this will be minus 1 s minus 1 power minus 2. When you differentiate it again, second derivative, so what it is, minus 1 already there, this power comes here, minus 2 s minus 1 power minus 3. So this gives you, when you simplify, 2 s minus 1 power minus 3. So here you will get your answer as 2 times s minus 1 to the power minus 3, which you can write it as 2 over s minus 1 to the power 3. Okay, so it doesn't matter which method you used, you are getting the same answer, 2 factorial over s minus 1 power 3, and here also same, because 2 factorial is nothing but 2 times 1, which is 2. So you can use any method that gives you the same answer, but this method is easier compared to the multiplication. So whenever you have choice to use shifting or multiplication, so always go for shifting property.